Here's a simple question. For a car, is it easier to accelerate in a standstill position or when you're already moving? My prediction is the second choice. And the answer to that is to understand the physics mechanics of a car. For starters, you must have preliminary knowledge of Newton's law and the field body diagram. If so, let's continue with our discussion of the mechanics of a vehicle. A vehicle undergoes two main different kinds of forces: the tractive force and the resistive force. The tractive force is what drives the vehicle to move, and the resistive force is what makes the vehicle to remain at rest or in uniform motion, according to Newton's first law. The resistive force is broken down into three different components. The first is the aerodynamic force. This is the force that resists the vehicle from moving due to the air pressure that is flowing against the direction that the vehicle is accelerating, also known as the wind speed. The second is the rolling resistance. This is the force that resists the vehicle from moving due to the friction between the tires and the surface at which the vehicle is moving. To put it simply, the more slippery the surface, the less rolling resistance, and the more sturdy the surface, the more rolling resistance that the vehicle undergoes. The last resistive force is the grating resistance. This force depends on the level of incline that the car is going. If the car is trying to accelerate from an uphill motion, then the grating resistance will try to pull it back down due to gravitational force. So combining all the forces together, if we take the difference against each force, tractive force subtracting the resistive force, that would equal to the resultant force, basically mass of the car multiplied by the acceleration, according to Newton's second law. Now, in order to prove my hypothesis correct, that it is easier to accelerate at higher speed, I would need to get a little more mathematical here, so get ready. If we isolate the tractive force on one side of the equation, we will get this kind of formula. Tractive force is equal to the resultant force plus the resistive force. Now, if we break down the resistive force into three composite forces and then break them down again, then our equation would get something like this. Then, after rearranging the terms together, we will now have two different terms on the right side of the equation. One is a speed-independent term, and the other is the speed-dependent term. As you can see, that in the speed-dependent term includes a velocity squared variable, and this variable dictates almost everything because according to the magnitude of the velocity, when the velocity reaches at a higher speed, that makes the tractive force to increase exponentially. Inversely, if the velocity is near zero, it would be very hard to get the car to even start accelerating because of the initial resistance. To illustrate such simulation, here is a graph of the tractive force versus the speed of the vehicle. As you can see, at low speeds, a large amount of tractive force is needed to get the vehicle in accelerating. But then, at a certain point, the tractive force decreases due to the speed-dependent variable that I have previously mentioned. You may have a question: why is the tractive force decreasing? And to point this out, it is the power of the engine. Power equals to the force multiplied by the vehicle velocity, and up at a certain point, the speed of the vehicle would reach to the point where the power, also known as the horsepower, would reach to its limits. This is why the tractive force decreases in order to compensate for a constant power region, and at the point at which it stopped increasing, that is the event at which the base speed of the vehicle is, the speed where it takes less force to accelerate the car. With a much more powerful engine such as a Lamborghini, it takes less time to reach the base speed, and for a less powerful engine, it would take more time to reach to that speed. Evidently, this reaches to the conclusion about the general knowledge about cars. It's not what makes a car powerful because of the top speed, but because of how fast it accelerates.